Okay, well, let's actually ask that. What if I had, Vincent asked a good question. What if I had limit as x approaches 1 of tangent of 8x over sine of 3x? Why was x equals 0 so special? Let's answer that question first. Why was x equals 0 so special in the original limit that we were looking at? Because cosine of 0 equals 1? Not quite. Cosine of 0 equals 1, I mean, was important. But why was x going to 0? Why are these two limits so, why do they need to be handled so differently? Sine of 0 makes the expression undefined, right? If I substitute x equals 0, I should say direct substitution, direct substitution of x equals 0, and this expression gives 0 over 0, which is undefined, right? So anything with 0 over 0 always has to be handled kind of with, kids' gloves, right? There's something else you have to do. There's algebra that cancels out, or there's some special property. In this particular case, we use that special limit, and we eventually got that this was equal to 8/3, right? After using the special limit. What's the deal with x going to 1? What if x goes to 1? Is that handled the same way? Yeah, we can just substitute like Aya says, right? X equals 1, tangent of 8 over sine of 3. Sine of 3 is not equal to 0. Sine of 3 is just some number. Jacqueline, why do you say it doesn't exist? Why do you think x equals 1 doesn't exist? The domain of sine? Well, what is the domain of sine? That's a good question. What is the domain of the function sine of 3x? Right, all real numbers, right? Because remember, x is kind of playing the role of an angle. Right, I was actually just going to say that. I think you were going to mix it up with the range, right? The values of sine of 3x can only be between -1 and 1. That doesn't affect what you can actually plug into sine, right? So tangent of 8 over sine of 3, that would be that limit. I mean, that's just some number. I mean, there's tangent of 8 radians over sine of 3 radians. I mean, that's just some stupid number. Put it in the calculator and see what it is, right? But there's nothing special about that because the denominator wasn't equal to 0. Now, a fun question, for teachers. I mean, not for you guys. Uh, so if I'd had, say, limit as x approaches, let's say pi. Ooh. What do you think about that? What do you think about x going to pi for this? Yeah, sine of 3 pi equals 0. And so Hirsch says, what did you just follow the direct substitution property? Not quite, because direct substitution of x equals pi, tangent of 8 pi and sine of 3 pi are both equal to 0. Ah. So this would have to be handled similarly to the second limit where we use that special limit sine theta over theta. Now, the only problem here is x going to pi does complicate things. Because, for instance, if you do the same sort of algebra here, right, if I go through the algebra, again, I get, say, sine of 8x over 8x times 3x over sine of 3x times 8/3 times 1 over cosine 8x, right? If I go through the same exact algebra as before, I actually don't quite get the correct limit, right? Because if I look at, say, this first limit, if x goes to pi, I do have sine theta over theta, but theta is not going to 0. Theta is going to 8 pi, not 0. So it's not quite the same exact limit. And in fact, this limit is actually much more difficult to do. You have to use some angle identities and the periodicity of sine to really get it down. So maybe actually maybe I should assign this problem as kind of an extra problem and see if you guys can figure it out, and then I'll get the solution online. So this is a different problem, and you should definitely understand why you're not allowed to just very easily use the special limit, right? And again, I'm pointing out here that if you just look at sine of 8x over 8x, theta, 8x is playing the role of theta. So it looks like sine theta over theta, but in this case, theta, 8x would be going to 8 pi. So that would be theta going to 8 pi. That's not theta going to 0. So you cannot just use the special, you cannot just say that this limit is equal to 1. No. It is. It is equal to 1, but you can't just use the special limit to say that. So I'll let you guys think about that, and then maybe I'll give you a little solution later in the week. I mean, you're not going to get something like that in an exam because we don't really cover that, but it's kind of a bonus question. Okay, another good question. Does the special limit only apply to sine? What do you think? What if I had x going to 0 of cosine of x over x? What do you guys think about this? Hirsch's question was, does the special limit only apply to sine? What about cosine x over x? DSP makes it 1. Rachel says it's 0. Wouldn't it equal 1? Well, what do we get? Hold on. What do we get from direct substitution? Yeah, we get 1 over 0. Ooh. So 1 over 0 we haven't actually talked about yet. 1 over 0 is going to be in the next lecture where we do infinite limits. So it'll turn out that, first of all, this particular limit doesn't exist. But we will be able to say, if I go from, say, the right side, I would get plus infinity. And if I come from the left side, I would get negative infinity for this particular case. But we will deal with this in the next lecture. And the reason why it's so much different is because you actually get 1 over 0. You don't get 0 over 0. The fact that 1 is a non-zero number is all the difference. A non-zero number over 0 always tells you that the limits actually end up being infinite. But that's for next lecture. So that's why cosine of x over x is different. There's no special limit with cosine. Your book might give you one, like your book might tell you, oh, you can also memorize, I forget what the Pearson textbook does this. Oh, 1 minus cosine x over x, that limit is equal to 0. That's correct, but you can actually, that's actually a corollary of the sine of x over x. So we don't memorize that. Okay, any more questions? So we actually are getting a lot of good questions, right? It's, how do you generalize these special limits, right? They don't really generalize as much as you think. Any more questions? Alrighty. So I'll leave that. I mean, I'll put those in the notes. Also, I'll kind of modify the notes. So it does only work for sine. Well, yeah, if in this form, right, sine of x over x. Cosine of x over x is just its own thing. It's infinite.